Let's look about how to describe chemical reactions. So in this lecture, be able to define chemical equation. That is a representation of a chemical reaction. Skeleton equation, this is the equation, but it doesn't have little numbers. It tells how much of each side there are. And then catalyst, this is a substance that makes the reaction go a little faster, but is not itself used up in the reaction. Coefficients, these are small whole numbers put in front of the formulas to indicate how much of each substance there is in a chemical reaction. And balanced equation, this is when you have the same number of atoms on both sides of the equations, representing the conservation of matter. Be able to convert skeleton equations to balanced equations, use proper symbols for chemical equations, and list the rules for writing and balancing equations. A chemical equation is a representation of what is going on in a reaction. As you see here in the CO2 plus H2O is producing C6H12O6 plus 6O2. This is an equation for photosynthesis. The reactants are those things that are going to, be reacting. Those are the things usually on one side of the equation where the arrow is pointing away from them. The products on the other side are what's produced during the reaction. And this is not a skeleton equation, because a skeleton equation would not indicate the relative amounts. You can see by the number 6 in front of CO2, H2O, and O2, these are the coefficients to tell you how much of each one of these is created or used in the equation. These are some symbols for chemical equations, and I'm not going to go over each one of these because you can pause and read, and make sure to draw these, and you will be expected to know them. In class, we're going to go over these on the board. I would recommend putting them on flashcards and the definitions on the back. This will help you to read equations. Yes, chemistry is another language, and we don't have the annoying Duolingo owl to remind you when to study it. Now let's talk a little bit about catalysts. You may be familiar with potassium permanganate. No? Well, you may be familiar with elephant toothpaste. What happens here is H2O2, or hydrogen peroxide, will turn into H2O and O2. It's probably happening right now in one of your supply cabinets if you have any hydrogen peroxide in your bathroom. However, if you add potassium permanganate, it turns into this way faster. All you have to do is add some soap and you get the oxygen stuck in bubbles, making elephant toothpaste. Now, the potassium permanganate is not used up in this reaction, and that is why it is a catalyst. It merely makes things go a lot faster, and as you probably know, it produces a fair amount of heat when things go a lot faster. So, balancing chemical equations. After you've written a skeleton equation, you can go back and kind of look, what would the actual balanced amounts be? And the coefficients are where you're going to place as whole numbers in front of the chemical symbols in an equation. If we had a recipe for muffins and I simply described all of the different ingredients, that would be your skeleton equation. If I said that you're going to take 7/4 of a cup of flour, then that would now be a coefficient. The problem is that 7/4 is not a whole number, rather is an improper fraction. And we don't use improper fractions when balancing chemical equations. The balanced equation has to have the same number of atoms on each side. And what we're going to be doing is pretty often checking out what is the lowest common denominator or least common multiple when we're trying to balance these. Yes, it's math, but it's math with numbers that are usually less than 10. Finally, some rules for writing and balancing equations. First, make sure the formulas are correct, that you're having H2 instead of H. Hydrogen gas instead of just random hydrogen atoms floating around in the void. Then write the skeleton equation. Put the reactants on the left, the products on the right, and an arrow in between. The arrow may go one way or may go both ways if it's reversible reactions. Separate compounds on each side of this with a plus symbol. Determine the number of atoms on each side. Remember that polyatomic ions can be a single unit only if they are going to be on both sides of the arrow. So if your ammonia stays on both sides of the arrow, then, that's going to be a single unit. Then you balance the elements one at a time. Use whole number coefficients and never change the subscripts. So don't turn that H2 into H3 just because it would balance better. No, that would be a highly unstable and downright dangerous thing to do. Then check each atom or ion to be sure the number is equal on both sides. Yes, you must double check this because often mistakes can be made. And then reduce coefficients to the lowest whole number ratio. If you have 12 of one thing plus 6 of another, could that be 2 and 1 instead?